Hey guys, so I'm making a video right now as notes to explain how to do trig substitutions. This goes with final review part, gosh, let me remind myself, part 7. So in that one, hopefully we at least starting to establish some things that you can do. But I'm going to go through an example from another resource. I'm like, what even is a trig substitution? So literally that's what I Googled. Trig sub, came up with a resource from Paul's online notes and math notes even, and they're quality stuff. I open up the first example here, and so I'm going to go through that example and just kind of give an idea of what's going on, and then hopefully that'll start to shed light on what is the process for doing a trig substitution. Maybe the difference that I notice here is he's using a square root and a minus, while our part 7 problem has a square root with a plus. Now that might come into play in whether we use a tangent function or something else. A trig substitution is a lot like a u sub, except for, well, it's part of like the process of knowing which one that you're supposed to be able to get to. So I'm going to go with their example. I'm going to go with the integral of the radical of 25x squared minus 4 all over x dx. And I mean, to be honest, I've gone through this problem a couple of times, just trying to like wrap my head around it to make sure that it makes sense as I get ready to present it to you. And even then, I'm still like, really? Okay. Key in on the fact that a straight up u sub will not work, right? This thing under the square root doesn't. Oh, that's fantastic. That little buzz was I got a notification to my phone. Note. Oh, there's a notification to you. Pinterest. Okay. So 25x squared minus 4, you just can't straight up u sub that because you will not have a way to eliminate the x at the bottom. An alternative path would be an anti-differentiation by parts. Perhaps that's going to be a useful thing. But I'm not going to go that road. This problem is designed to use trig. So instead, they just right out of the gate, barf out x equals 2/5 sine secant theta. I mean, I find it to be incredibly like, yeah, this is a barfy answer. Now, the back pedal for it actually focuses on the square root. Like if we focus on the square root, we might have some meaningful information. Focusing on the square root tells us that, gosh, what other things in math have we seen since 8th grade that deal with square roots? And trigonometry is a study of, right triangles. If we draw a right triangle, and we label the sides A, B, and C. I'm going through this because this is actually like my second run through. My first one I would have shared, but it was just so trash. So in trying to explain it, they don't even do a really good job of explaining it until they get down to this section right here. Would you be at all unconvinced if I said A squared plus B squared equaled C squared? Would that bother you? It doesn't bother me. Would you further be bothered if I said b squared equals c squared minus a squared, right? I mean, why not? So if we square root both sides, we get b equals the square root of c squared subtracted by a squared. I gotta admit right now, my facial expressions are all like Matt Parker from Stand Up Maths. Check out his channel. I'm really not trying to like channel that right now. Channel and channel, two different uses of the word, but I really feel it too. Anyway, so I'm noticing that the structure of 25x squared minus 4 looks a lot like c squared minus a, which means c is 5x, which is what they have in their example, and a is 2. So using Pythagorean theorem, we can set up this understanding, this way of relating things that are the square root. Let's get the square root out of here. Get the square root out of here. That means that we can have 25x squared minus 4. That's really muddled with a Sharpie, but that's going to be the opposite side. So we have this relationship of 3 sides of a triangle. SOHCAHTOA, love it, also lets us have CHOSHA-COW. No one ever told you this before. I came up with it like last year. So CHOSHA-COW really does mean that secant, I'm focused on secant because of the use of non-square roots in this triangle. Secant is hypotenuse over adjacent side. So I don't even know why I put like A as 2. I don't have a good answer for that, so I'm just going to let it be for right now. But maybe if I focus on secant, it's going to be a positive. Anyway, okay, so, or nothing to that comment. So secant of theta is the hypotenuse over the adjacent side, 5x over 2, which means x equals, are you with me now? X equals 2/5 secant theta. I bet we're just going to take all of that and plug all of that into that formula. So integral, here's our trig substitution, of 25 times 2/5 secant squared of, squared, not yet, not supposed to know that yet, secant, this whole thing is squared, minus 4 square root that radical, sorry for crossing you out, little 2, over, not x, 2/5 secant theta d theta. Now there's a reason for it to become a d theta. Up above, they do something. Oh, this is what they do. So I'm actually missing another step. I need to differentiate both sides here with respect to theta. That makes dx d theta equal to 2/5 secant theta tangent theta. Putting d theta over there means that all of this is dx and it's going to go right here. 2/5 secant theta tangent theta. I'm running out of room. Okay, it's there. Promise you it's there. I'll make it make more sense. You know, when you're like not planning ahead. I did that, and hopefully when you start seeing things where there's a giant fraction bar and there's stuff on top and bottom of the fraction bar, you just want to cross it out. So 2/5 crosses, secant crosses, and 2 will be squared, 5 will be squared, and secant, I already said it, so secant will be squared. 25 over 5 squared, boom, boom, those are gone. So I really am left with 4. Debating if I should write it this way or jump to another trick. Tangent theta d theta. Okay, that's a lot. I'm not done. We're not done, but we're one step closer. Are we lined up with what they're doing? We're one step closer to the process being done, because in getting rid of a lot of things, we're winding up getting ready to have one thing, and having one thing lets us do an easy, quick integral, and most of the questions that you've been given are easy, quick integrals. You shouldn't be spiraling dangerously. Okay, keep this video under 10 minutes. Here we go. So the 4's I can factor out. You see that they do. No, you don't. They show the 4's factoring out in the Paul's Online Math Notes a little bit earlier. So if the 4's factor out, it's square root of 4 times secant squared theta minus 1. So this is going to become the integral of 2. That's where the square root of 4 happened. Integral, I'll just write it and then I'll fix it. Secant squared theta minus 1 times tangent theta d theta. But guess what? You're kind of seeing, you know, in the online notes from Paul, that tangent squared theta, this thing right here, now I'm calling on Jeff Goldblum, this thing right here, yes, is tangent, yes, and because it's a tangent, we can then write it as, how was that guy ever an actor? The integral of tangent squared theta d theta. Oh my gosh, I'm on a new page of notes. I don't even have the integral gone. That weird little line right there is just because, you know, Sharpies are Sharpie. Oh, intriguing. So they take theta and they put it back into terms of x. So like right here, I'm about to take the integral genius. Okay, so right here, I'm about to take the integral tangent squared. There's another trig sub. So we're at this stage. 2 integral tangent squared theta d theta. But wait, there's more. Tangent squared theta becomes secant squared theta minus 1 d theta, and we're integrating, which therefore means that we have the integral of 2 secant squared theta d theta minus the integral of 1 d theta. So we're left with this right here. That's the derivative of tangent. Derivative. So its antiderivative would be tangent. So 2 tangent theta. Oh, they already have that right here. I don't know why I'm hiding. Minus theta plus c. Don't forget the c. That's not in terms of x. What do they do? Oh, they go back and they solve for x. Okay, so solving for x gives us a side note. X equaled 2/5 secant theta, right? Are those the notes or those the old notes? I feel like you got it backwards. No, I got it right. 2/5 secant theta. So solve this. Sorry, arm. Solve this for theta. So 5 and 2 secant theta. Why am I doing? Just get to the answer. It's right here. Secant inverse of 5x over 2. All right, so since secant inverse of 5x over 2, we can plug that in there, This gives, why would we do that? Oh, that's nice. They flipped the thing. They say that theta also equals cosine inverse of 5x over 2. They're able to do something with this. What are they able to do with this? Tangent of theta. I wonder if we bring this back in. That would be this over this. Why not? Definitely why not? Okay, so bringing back in the triangle that was in part of the problem, tangent of theta is square root 25x squared minus 4, all of that over 2. And then, because, well, there's 2 of them. There's got to be a 2 there and a 2 there. 2. Theta is now expressible. I mean, cosine looks better than secant. So cosine inverse of 5x over 2 plus c. And you know what? With a little nod to Paul Helmos, we're done. Not done. Now we're done. Now we're done. Oh my goodness, this video is so long. Feel free to not watch any more of it. Although I haven't actually answered how you do the math. So let me just get you started on the prep. So we have 1 over square root 4x squared plus 9 dx. Just checking. My memory for you. Okay, so I'm going to apply at least just this much information. I'm going to think about this in terms of like theta, in terms of what we can then swap out. So if I think about this as a squared plus b squared equals c squared, this might be 4x squared plus 9. What does that make the opposite side? 2x. What does that make the adjacent side? 3. Since that's what that makes it, then we can write out sine, cosine, tangent, etc. as, let's go tangent. Tangent of theta is opposite over adjacent. I don't know why I put the 2x there. Maybe because I want the x to be, you know, in the top part of the fraction. Tangent theta is 2x over 3. Solving for x gives us tangent theta times 3 divided by 2. I'm going to take this. This is the information from those previous pages, right, of notes, is that in this problem up here, my trig sub is to make this go in there. And I'm trying to maybe force it so that x is positive. I'm using sine, cosine, tangent, not cosine, cosecant, secant, or cotangent. Try to force it to be those main three. Although we had one over in the previous example, whatever. Okay, so then in this problem, we're going to swap in 3/2 tangent theta. So that's going to be the integral of 1/4 times 3/2 tangent theta squared plus 9. All of that is square rooted. Man, it looks like the problem got longer. Okay, so then 3 is squared, 2 is squared, tangent is squared. That gives us 4/4. So then 4/4 will cancel. 3 times squared. 3 squared is 9, and they're both 9s in there. So I'm going to factor out a 9, leaving me with tangent squared theta plus 1. That may be significant. It's still square rooted, so square root that, and it's all over 1, and then we have dx. I think for right now, I'm going to lead you down that trail and say, can you dig your way out? And reserve some time for Tuesday or Thursday live session to go over it if you want to go over it. Anyway, this video is already over 15 minutes long. Mea culpa. And I'll cancel it there and upload it, and then you can watch it at your heart's content. Please feel free to double time it. Thanks for watching, commenting, liking, subscribing, and clicking that bell. And I'll let you handle the rest. Thanks. Bye.